Again, I'm Sergey, Program Director of AI Curation and Professional Tools Unit of Intento, and Intento helps global companies to onboard AI. And today I want to have a 20 minutes talk to you on MT evaluation, MT curation, and what we took from agile practices. Sorry if I would jump from topic to topic and from point to point, because there are a lot of things I want to say to you. And let me start with the classical approach and what we saw when we just started our evaluation. Now we do, I think, hundreds of them, I think several hundreds already. And when we started, and even now, we saw that for so many companies and for so many people, MT evaluation is still a waterfall process when they start from training MT and then go through all of the steps, through all of the stages to post-edit an MT report and get the answers, did they guess or not, only at the end. But each step, each part of this waterfall process has their own pitfalls. And let's briefly go through them to understand why they can bring havoc and mess to the final results. First of all, we see that some companies and some people use all the available data they have to train their models. They train models with all the junk they have into their TMs and with all inconsistencies, and then they have the scores from providers, from Google, from Microsoft, and they see that blue grows and they yell, hooray, we have grown blue, we have improved MT models. But two really important things here. First is, maybe some of you know, I'm sure that you know that blue is parameterized metric, and that means that when you go to Google and see blue of your new model, and let it be equal to 60, and you get your blue from another provider, for example from Microsoft, and it's 61, it really means nothing, because the exact blue score you have from different providers depends on the parameters they use to calculate it. So is it 60 or is it 61? If the scores are calculated from in different places, you cannot just compare them. That is the first thing. And another thing is, even if you have average improvements and growing scores, at the same time you can have these showstoppers and these really critical issues on the segment level. And that is why they dive deeper and took the sample for human evaluation. But we see that people still use this random sampling. And random sampling is, imagine a blind giant who wants to build the map of the area, and he walks through his land and he can overstep the canyon without even mentioning that it was there. And that is random sampling. With random sampling, you can miss all this important part with important signals, which really changes the result of your evaluation, and which where can be showstoppers for you. Then next thing, even with this random sampling, they go to human evaluation, and that is the most time and costly part of the evaluation, and that is why everyone tried to reduce it. Reducing the human evaluation is the right step, but do not sample output. Do not decrease the amount of segments for human evaluation with random sampling. Or we also saw that some can just skip this step and said, okay, we have good scores, let's proceed to production. And then when they get PMT report, it is too late really to change something, because PMT report shows you this efforts and this money and this time you already spent on changing the MT output, on editing it. So if we take this on a plot, we see that the cost of errors accumulates from step to step, and if during the post-editing report you catch the error which came from data cleaning, you have to go back and step by step go through all over the process again. And maybe even with the same data, you will have another results because of the random sampling. Because with random sampling, you get different results with the same data set. And that is where this idea grows, how to fix it. And two main things. First, short iterations, and second is smart sampling instead of random one. Short iteration, where can we see this? And I'm sure for the last 5, maybe 7 years, you all saw this picture for so many times. Maybe you already tired of it, all this agile sprints. But that's what we did and what we suggest. That does mean that we took the whole agile practices and just copy and paste it to evaluation. No, we just applied those parts which really applicable. Short iterations with tests, review, and decision-making point on every of them. So we clean the data and we do not proceed to the next step before we check everything, before we test everything, and before we decided that it's okay. Then we train the models, and we do not immediately go to human evaluation. We check how well this model trained and decided, should we go further or should we retrain the models? And sometimes we train several models on different data sets for the same clients to decide which one is better for them. And now if we look at the same plot, we see that we catching errors on every stage and we do not let them accumulate. And once you catch it, you do not have to go several steps back, or from PMT report to data cleaning. You can just reiterate the last one, or maybe two previous one. If you're talking about training analysis, of course, sometimes there you can have issues came from data cleaning. Then yes, you have to run 2 steps, but not 5 of them. And that is how our evaluation looks like now when we apply this agile approach. We have 6 big steps, and between 5th and 6th one, we have part which are on the client side when they review the exact segments we extract for them. And on the bottom of the slide, you see the timeline, and that is the time we reached with our approach. And now, why don't everyone do it? Why we cannot just say, okay, switching to the new approach, let's do data cleaning in 4 hours, and let's do training analysis in 30 minutes. Because company not only have to have methodology, they also have to have tools for it. And of course, we started from the internal automation, and first we automate everything for us internally with the scripts. But then when we decide that when we see that there are a lot of companies who want to curate or evaluate or train models on their side, we started to pack it into MT Studio, the pack of tools for MT curation. And those of them who are blue already, you see that's only half of them. So I hope soon we will cover the whole process. And now I want to dive deeper into the steps, not to show you how cool our tools but to show you how exactly we apply this agile evaluation into the steps. Yes, we're still starting with the data cleaning that is necessary because as I mentioned, if you train your models on junk text, on the junk translations and inconsistencies, you will have mess in your model. So yes, we start with the data cleaning, and we use 40 filters, split it into 14 steps. So inside of data cleaning, we have 14 steps with parameters. Of course, we have a lot of projects in the past, so we have this default values for every language for data cleaning. But after each step, analysts take a look at the removed segments or modified segments and decide, is everything okay? Can we proceed, or should we have to go a step back, change parameters, and reclean the data on exact this stage? And as I said, during the data cleaning, we not only remove segments, some of them just modified. For example, we substitute regular spaces for unbreakable spaces, and we remove all the bullet points. We had this experiment when we left the bullet points, and one of the providers started to add them randomly in the output. So agile data cleaning here is to have several steps and check the results on every of them and rerun the step if you see that anything go wrong. Right after we clean all the data, that is still an internal script. I hope we will release it soon. We train all the models available for this language pair. And here I want to say a few words about another part. I already told you about this agile approach with this search sprints and iterations, but I also mentioned that you have to sample smart, not randomly. And here is the idea. To have the reliable results, you have to have a lot of data on the one hand, but on the other, only people can decide which output is better for you, because languages and linguistics not a math still, and you cannot rely on the scores or metrics only. But scores and metrics can help you to extract exact those segments to be reviewed by people, by human, to with the most significant signals. So you have big pool of data, and you do not spend time of your analysts and of those who make decision on all of them, but instead you use metrics as filters to extract small groups of segments for human review. And right after we train the model, we do not proceed further before we check how well the model trained, and we have special tool for it, customization analysis. And it again, back to this picture, we have 2,000 segments as this example on the picture, and the tool highlights you only 3 to 5% most degraded segments, because after you train the model, even if you see that your scores, the average score grows, and that means that in average your results are better not better, closer to human in MT evaluation in all the scores. Of course we say better or worse, but you must understand that high scores means that MT output closer to your human reference, and lower score means that it's further from your golden reference. But human golden reference is not always as golden as the owner expects. So yes, we see that even if the score grows, we have a group of segments which really degraded, and our analysts dive deep into these segments and see which new issues we have there. For example, if we have the emission and our client case is support charts when emission is critical, we cannot recommend them this model because even if the average score grows, we have critical issues for them. And that is how with reviewing only 3 to 5% of segments, analysts can decide what the MT training results good enough or not. Should we rerun this step? And they do it really in 20 to 30 minutes. And after that, after we decided that all models trained well and all the customized MT output better than stock ones, we do not have to retrain models, we do not have to reclean data, we proceed to the next step. And here again, with Intento scoring, we reduce the amount of data, this big pool of data. We get all the outputs from all available providers for this pair, because at the beginning we do not know where to expect the best one, and we see this tail of outliers with average score, and that means that you do not have spend your time on this providers. Most likely your best fit would be among the top runners, this head. And again, you cannot just stay with the first one. You cannot just decide, okay, this MT number one has the biggest average score, that means it's the best for us. No, there's still hidden pitfalls inside them, maybe, or maybe not. So we have to evaluate this the whole group of top runners. And here, really, analysts can decide in, I don't know, 3 minutes on the with plots and with scores where is the top running group and where is the outliers. So in 3 minutes, analysts reduce the amount of data for human review in half or even more. Then through this top runners, we using again different filters, different metric filters. We extract different group of segments with important signals and send them to human review. And here, for you just to understand, here to when we calculate all the scores, we have about 900,000 to million words, and after 2 steps for human review, we extracted only 10,000 to 50,000, and it's 1%, 1.5% of data for human review from the initial pool of data for evaluation. And there we have only those segments which really brings signals. So analysts and those who review the output do not have to spend their time on unnecessary things and unnecessary segments. And after all, we took files back from reviewers. We calculate everything they do. We measure post-editing distance. We measure effort savings. We calculate all the weak spots for all the providers we have, and we prepare this report. Usually it's about 50-page in report with a summary, special page with summary for top managers, because they do not like 50 pages, they like summaries. And that is all. Before we proceed to questions, let me for one more time go through the key takeaways I want you to have. First is do not go through MT evaluation or MT from start to the end of the waterfall, but after every small iteration, stop and make decisions. Second thing is sample smart, not randomly, because with random sampling you can miss very important parts and very important signals. And the third one is to apply this methodology. Of course, you need to have tools. To have tools, you can create them on your own. You can use Intentos. You can use tools from other companies on the market. That's not so important. Important is do not guess, but evaluate and measure. That is all, Leonid. I think it's time for questions.
Well, first of all, Sergey, thank you very much indeed. And now we'll proceed with the questions. I hope we have some here in the audience. Okay,
Leonid, one more thing. I do not hear you so well. If you can, if your engineers can make sound louder for me.
Okay, do you hear me now? Perfect.
Perfect. Thank you.
So they've done something. Okay, Fyodor has the first question. And okay, nobody is close with the microphone, so we'll share it. Oh, he has it. Perfect.
Hello, Sergey. I have actually a few questions. First of all, what's the average size of training data corpus?
That depends on how much
you usually use.
That depends on the amount of data client has. Of course, we start with everything they have, and then we clean it. So the most usual question is which is the lowest amount of data we have for evaluation and for model training, and we have a record. Once we saw that customized model trained on 5,000 segments overperforms the stock model. But that is a rare case, and we do not have upper threshold, just low one.
Okay, thank you. And second question, how do you think, let's say we have a big project for machine translation, and how big should it be for us to create some trained MT model? Where's this threshold between using stock model and just editing the text a bit more, or spending lots of time and effort to create clean and maintain trained MT version? Thank you.
Well, then you have to calculate it, and you can calculate it based on how much you get from the project in money, not in time or in anything else, and then just calculate can you spend enough of it for MT evaluation for you as a service or as a tool, as tools. So I do not have the exact threshold here again, but you can reach out to us and we will let you know how much the tools cost and how much the services cost. We will just decide that the ROI good for you or not.
Okay, thank you. We'll keep in touch about that. Thank you very much.
Okay, Konstantin has a question.
Можно по-русски?
Is it okay if I ask in Russian? Yes, absolutely. So, Sergey, when it comes to tools, is there anything which could work with some corpora which one can buy or download? In particular, if I want to recognize in the very corpus some degraded segment of, degraded data. So we have some fragment which is absolutely wrong, bad alignments, the target is absolutely inconsistent with the source. Is there anything amongst your tools which could help to identify such tools and to clean them? Yes. We have such metrics, we have labs as a key one. So there are always some metrics which we employ whether they correlate with some others. So for each particular project, we have the key, the main metrics, and we also have some additional ones. And if we see that the results are comparable, it's fine. Then if we see something different, then we delve deep into that and we try to understand what is the nature of the issue, what are some distinguishing features that we can recognize. Well, unfortunately, I didn't hear the first part of the question because we purchased data set and there is something wrong about that, you know. How do we find this fly in the ointment? Yes, we use the matrix, and then we try to find this MTQ from model front. We use 4 different ones, and we have our own in-house tools, and we use labs matrix. Fine. We understood. Okay.
Any more?
To
Okay, my last question then. So which is the smartest step among the steps that help you select the most representative segments?
Again, the languages, and I missed the first part of the question.
Okay.
Can you please repeat?
Which step would you consider the smartest one? Because you mentioned selecting segments to analyze smartly, not randomly. So which is the smartest part of it?
The tricky one. Okay, for us, where we save most time. First, when we compare output of customized MT to the stock one, and not only customized stock one. When we uptrain models, for example, after the year, with the data, we always compare output from the new model with the previous one, not only to the stock. And there we dive deep into, as I mentioned, the most degraded segments. And that really saves us a lot of time, not to go through all of this, but go only there. That is one thing. And another thing is weak spots when we compare segment by segment scores of output from different providers, and take a look at spots when all the outputs from all the providers are good and only one shows something strange or something critical. Then we dive deep into exact this output and see what's going on here. That is also a good example of smart sampling.
Thank you so much. Any more questions here? No. So please, your round of applause for Sergey, and thank you so much for being with us.